Okay, so let's continue with the 4.2a notes. Now we talked at the end of the last video that you can always interpret slope and what it means. But what about the y-intercept? So sometimes you have to ask yourself two questions. We talked about briefly at the end that your data can't be too far outside of the values you've seen. You have to ask yourself, is 0 a reasonable value for the input? In the case of studying from the last video, yes. Do you have any values near 0? Yeah, you had some people close to 0, in which case both are yes, so you could have interpreted the intercept. But if you don't have any values close to 0, or 0 doesn't make sense for a value, sometimes your intercept is negative. So if your intercept is negative, you're like, well, could I have gotten a negative 30 as a test score? No, probably not. So there's a little caveat there. But generally, never use your regression line to predict values that are far away from the things you saw. So if you looked at people between the ages of 20 and 30 for your data, don't be using that to predict the behavior of someone who's like 90 years old. That's too far away. Or don't predict it to use it to predict a baby's behavior. You kind of stay within the scope of your investigation. So we're going to do another problem. Work it from the beginning to end, not only to see if the regression can be made, but what steps need to be taken in order to make sure this works effectively. So the chart to the right gives the age and blood pressure of 8 men. Make a scatter diagram. So the scatter diagram is just where we plot the points. It looks like our blood pressures go from about 100 to 200. So what I'm going to do is jump from 0 to 100 and then go by 20s. And go up from there, 200. And then to the right, we've got age. Our ages look like they go from 16 to 70. So we'll go 10, 20, 30, 40, 50, 60, 70. Okay, it's 10. So the 16-year-old has about a 109 blood pressure. 25-year-old, 122. 39-year-old, 143. 45-year-old, 20, 30, 40, 45-year-old, 132. 49-year-old, 189, goodness, it's way up there. 64-year-old, 185, 50, 60. 70-year-old, 199. I know it's going through the make a scatter diagram, but it's fine. And a 29-year-old, 130. Now roughly you can see from left to right, it does look like the points are going up, so you probably expect there to be a linear relationship of some kind. So calculate the sample coefficient. That's the R value. So again, to calculate your R value, you do it in your calculator. I'm going to go ahead and put the data into a website. 16, 25, 39, 45, 49, 64, 70, and 29 are our ages. Also, if you're going to put this in on a website, just like if you were going to do it in your calculator, the order you put them in matters. Make sure your X's and Y's go together. And then calculate the R value. My R value is, looks like 0.9199. And check if it's strong enough to use. So we have 8 data entry, and it says for 8 entries, I need at least a 0.707 or at least a negative 0.707. And 0.9199 is greater than 0.707, so we do have a strong correlation. And lastly, if we have a strong correlation, then we can find a regression line. We can do it all the time, but you don't really want to use a regression line unless you have a strong linear correlation. So I'm going to put the same set of data into my regression line calculator. And when I do that, I get the equation. Okay, we get the equation. Does look like we have a positive slope. Okay, we've got an equation of 1.69 times your h plus 79.76. We're gonna go to 2 decimal places. Okay, so what that means is every year your blood pressure goes up about 1.7. It's not uncommon for older people to have higher blood pressure generally, but that's the regression line, and I want to use it to predict the blood pressure of a 90-year-old man. All I have to do is plug in 90 for x. So 1.69 times 90 plus 79.76. Now you could be asking, well, that's a little bit outside of our scope because the oldest person that we actually tested was 70, but that's not that far away from 70. It looks like 231.86, which is about 232, which is really high blood pressure. Now, what would we have done what do you do if you don't have a strong correlation? If you don't have a strong correlation, how do you predict a y value? Well, we don't want to use a line that's not a good fit. We use the average of the y values. If two things aren't related, then our best way to predict a variable is just to look at the average of all of the numbers. So if we didn't know, if age wasn't related to blood pressure, and we wanted to predict it, we would just find the average of all the y values and say, well, that's the average, so since these two aren't related, it could be anywhere, so that's what we would do. And we'll see an example of how we use that in this 4.2c on the next video.